the categories that we're going to put all the enzymes in and names of some enzymes, let's actually talk about how enzymes work and what helps them work. When there's a chemical reaction and an enzyme is needed, the reactant, which is on the left side of the arrow, is now going to be called a substrate. It's not called a reactant anymore. Remember, in intro chemistry, you had the reactants on the left, and then you had an arrow, and then the products on the right? Well, now the reactant or reactants are called substrates. Here's the word substrate, S-U-B-S-T-R-A-T-E. So I've got over here the enzyme plus the substrate. So the substrate binds to the enzyme at an area called the active site. Active site. So once the substrate binds to the enzyme at the active site, we now have a complex called the enzyme substrate complex. All right? That the substrate binds to the enzyme. The cool thing about the active site is that it fits the substrate pretty much perfectly. You can have a little bit of wiggle room, but this substrate will fit in this active site of this enzyme. No other substrate will fit. So let's say you have the enzyme sucrase, okay? The enzyme sucrase, what will it do? It will catalyze the hydrolysis of the glycosidic bond between glucose and fructose. Remember, the structure of sucrose was a glucose and a fructose in that 1,2 glycosidic bond. Well, the enzyme sucrase will fit in, so will a molecule of water, and then they will collide with each other and right at the active site, and then the sucrose will get turned into glucose and fructose. Well, lactose comes and it wants to fit. Lactose doesn't look like sucrose. It cannot fit in the active site. So just remember, the active site of an enzyme is very substrate specific. Once the substrate binds, you form this enzyme substrate complex. Then, once the reaction occurs, like for the situation with sucrose gets broken into glucose and fructose, those are the products. And then guess what? The enzyme is ready to do it again. Okay? So the enzyme, by definition, doesn't get consumed in the reaction at all. The substrates get turned into products. The enzyme stays as an enzyme, ready to do it again and again and again. Okay? Now, there are some enzyme helpers, and these helpers are called cofactors or coenzymes. The cofactors, especially if we call them the inorganic cofactors, those are usually metal ions, usually magnesium ion and a zinc ion. Do you guys remember the word ion from intro chemistry? An ion is just a charged atom, okay? And Mg is magnesium and Zn is zinc. Those guys, like you have over 200 enzymatic reactions in your body that require these guys, all right? So they're very important. It doesn't mean you go out and you pop some magnesium and zinc pills. Just get a nice healthy diet with lots of good fruits and vegetables and protein and all that. You'll get plenty of these two minerals that behave as inorganic cofactors. What is an inorganic cofactor? It is something that helps an enzyme. So there are some enzymes that can work without any cofactors. Those are called simple enzymes. But conjugated enzymes, they need a helper. They need something to help them do whatever they have to do. The enzyme I was working with, tyrosine kinase, if I forgot to add the magnesium, nothing would happen. No product, nothing at all. Okay, so you do need those cofactors for some enzymes. Now, the word coenzyme, these are organic cofactors. These are organic cofactors, and these are all derived from B vitamins. Okay, here. The B vitamins are water-soluble vitamins. You know, B and C are water-soluble. A, D, E, and K are fat-soluble. Remember, we mentioned the fat-soluble vitamins as being stored in your lipids, and that's one of the reasons we need fat in our diet to store those fat-soluble vitamins. But B is water-soluble. So B vitamins are so important in your diet. A lot of people think, oh, they give me energy. No, they don't give you energy. They are just the precursor for these coenzymes. So your body takes in the B vitamins and then turns them into some important enzyme helpers. So what are these enzyme helpers? What are these coenzymes? Let me give you some examples of these coenzymes. And if you've had a bio class, you may have heard of them. NAD is a coenzyme. FAD is a coenzyme. Coenzyme A, just from the name, is a coenzyme. TPP is a coenzyme. PLP, coenzyme. So these are 5 different coenzymes that are so important in a bunch of enzymatic reactions in metabolism. All right, we probably won't cover them all in metabolism, but I want you to know the acronyms. You don't need to know the full name. NAD is nicotinamide adenine dinucleotide. You can look it up. FAD is flavin adenine dinucleotide. Coenzyme A is just coenzyme A. TPP is thiamine pyrophosphate, and PLP is pyridoxal phosphate. Which B vitamins are these guys derived from? NAD is derived from B3, which is niacin. You may have heard of niacin. This is vitamin B3. Your body takes it in and makes NAD. What is the purpose of NAD? It helps an enzyme do its job. In fact, so many of those dehydrogenase enzymes, you remember the category oxidoreductase, they need NAD in order to get the substrate and turn it into a product. And the NAD is there to get reduced, pick up some hydrogens, get turned into NADH, and then we use that to make ATP in the electron transport chain. We'll get into that in metabolism. But what you need to know for this chapter, NAD is a coenzyme. It's derived from vitamin B3, or the name of vitamin B3 is niacin. Okay, FAD is flavin adenine dinucleotide. It's derived from vitamin B2, and the name of vitamin B2 is riboflavin. If you guys have a bottle, a multivitamin bottle at home, just look at the label, you'll see the names of these vitamins. Or even sometimes on a cereal box, flip it over, you'll see these B vitamins, because they fortify the cereal with these B vitamins. CoA is derived from vitamin B5, and this is pantothenic acid. Pantothenic acid. That's the name of B5. TPP, derived from vitamin B1, and the name of it is thiamine. And then finally, PLP is derived from vitamin B6, and its name is pyridoxine. Okay, so these are some key B vitamins. You should have them in your diet. Why? So that your body can use them and turn them into coenzymes. And then what do the coenzymes do? They help the enzyme do its job. So if an enzyme is there to catalyze a specific reaction and it needs a coenzyme, if you don't have that coenzyme, that reaction will not occur. Okay, so that's the purpose of those coenzymes. All right, good. A couple of other words I have here. All right, I already mentioned simple enzyme is an enzyme that doesn't need a cofactor, okay? Conjugated enzyme is an enzyme that needs a cofactor or coenzyme, okay? And apoenzyme is an enzyme that needs a cofactor, but it's missing that cofactor. All right, there are a couple of enzymes where if it's missing, the apoenzyme is just then useless. It can't work. All right, good. So in the next video, we'll get started with talking about things that affect enzyme activity, and we'll talk about inhibition, and we'll wrap it up with the different theories, lock and key and induced fit, and then we'll be all set with this chapter. All right, good. See you in the next one.